Hello everyone, I'm Aryan. I am a security engineer at Blue Flag Security. My work goes around product engineering and security research. This talk is about PostgreSQL security. I kept the subtitle as bare minimums and when best isn't enough, but I did not define what best is. Best, how I have been thinking about is best is some general standard practice that people have been telling you to follow to keep your database secure. However, in this talk, my plan is to keep the talk into two sections. The first part is about the first part is about the bare minimums that you have to do to make sure there is reasonable security, and then I'm going to walk you through on how exactly the walls that you have been creating in your PostgreSQL instance can breach. What are the different kind of attacks that can happen even when your best practices are there. So there's a lot of content to cover. I am not gonna. I would request you to keep your questions for later. Yeah, I'm just gonna rush through the slides. So starting out, wait, this isn't working. Okay, I'll probably use that. So starting out, the bare minimums. The first challenge that we have is that initdb allows passwordless authentication for local users. What it means is if you take a look here, the first rule says local connections, and then it's using peer authentication, which is fine. People use peer authentication for Postgres user, but then you see this line: local all peer. Now, what's happening? What peer authentication is? Peer authentication checks for the local OS name once you are logging in. If the OS operating system username matches with any DB role, it's going to log in you as that DB role directly. Now, this is fine. It's a good form of authentication, but then the problem is, what if I could use sudo to gain access to root, and then I can change myself to Postgres user? Now I can access my database as a super user, which generally works in constrained environments, but it can also allow you to. It can also create some kind of risk in multi-user environment when multiple users are using your database instance. Maybe there is someone who can escalate privileges, gain access to super user, and suddenly they have access to everything in your database. The next problem is, what if your server itself gets hacked? Now whoever the attacker is, they have access to this. They have access to super user role within your Postgres instance. So how do you prevent it? Ouch, it's still not working. No way. Okay. How do you prevent it? You enforce password authentication for user. Now, this is not something I'm saying as a standard practice. What I'm saying is it's one of the suggestions that you can use. You can set up scram-based authentication for your super user. What's going to happen is when you're trying, even when you are root user for your operating system, you still need to put in a password in your database instance so that you can log in as the super user. The next steps that you can take are enforce in non-interactive sudo. What this means is whenever instead of logging into Postgres user as using the shell, you will use certain commands. You will gain access to only the commands. So you cannot really gain Postgres shell. What you'll do is you'll use pSQL using Postgres user. Then the next option is the next suggestion that I have is, when you're using initdb to create a new database cluster, use -a parameter, which will allow you to set up an authentication. Say change your authentication mode. The -w flag is for creating a password prompt. So if you're using this command to create a new database cluster, what's going to happen is, by default, your Postgres user, which is your super user, will be using scram_256, and it's going to ask you to put in the password. So there's this extra step of security that you can add. However, if you feel like peer is something you want to use because Postgres user you're using Postgres user to run in some scripts, what you can do instead is use require peer parameter in your client connection. So this will, what this require peer parameter does is, it looks at who is the operating system user that was used to run your PostgreSQL server. So it's just an extra layer of security. But if you want to use your password, there's also this file called .pgpass, where you can store your password in case there's any other process that needs to use it. To the next slide. Because I already talked about peer, I'm not really going to get too deep into it, but peer is not something that I want you to take away from this is that peer is not a bad form of authentication. It's problematic when you are using it in multi-user environment, because if there's another user who can access your data, who can access the operating system, what's going to happen is they will probably try to escalate their privileges at some point, and then they can have access to the super user. So you want to prevent that. So if you are restricting your access, if you're restricting your sudo access, peer works very well. Next. The next challenge that I'm going to talk about is not using alter user set password or with password. The challenge is the moment when you start using this query, alter user with password, what's going to happen is it leaks your password in two different spots. One is your command history. So if you look over here, I used create user, then I used this alter user with the password. I quit my I quit PSQL, and then I checked the PSQL history. I could see the commands that I ran with the password. Same went with the logs. If you're logging the DDL queries, what's going to happen is you can see the password present in the logs as well, which is something you want to prevent. Next slide. So walking to and fro is a bit of a challenge, but yeah, I'll try to make it quicker because I've already done through 10 minutes. Okay, prevent network snooping by setting up SSL. So snooping is when you are having communication with someone and someone starts eavesdropping you. How do you prevent that? You set up SSL, which is a standard, pretty much everyone knows about it. When I started looking into how exactly PostgreSQL has been setting up SSL, what I found was that when you're using PostgreSQL 17, it's already setting up SSL for you. However, there's a challenge. It's using something called snake oil certificate. This snake oil certificate is a placeholder certificate that your operating system provides for you. It's not secure. It's a self-signed certificate. So if you're so when you're setting up SSL in your PostgreSQL server, do not use this. Instead, create your own certificate, get it signed by your intermediate CA or your company's certificate authority, and use that certificate. The next option is to restrict listen addresses. This is an incredibly important part of securing your database, because with this, what you're doing is you're preventing unauthorized users from accessing your DB. If you know who your clients are, you can simply give them the access instead of everyone else. So restrict listen addresses. The last line is using host SSL instead of using host SSL everywhere. What it does is when you're trying to establish a connection, host SSL will make sure that SSL is enabled. If there's no SSL, it won't allow a connection. So on to the next. Yeah, thank you. On to the next slide. The next one. Now I'm going to talk about what are some potential problems with the best practices, and I'm going to start with SSL. So there are only two type of attacks that I'm going to talk about. The first one starts with SSL. SSL does not prevent spoofing. Spoofing is when your application server connects with another server thinking it's a client, but thinking it's your PostgreSQL server. But the problem is, how do you know if that's actually your PostgreSQL server? What if there's an attacker sitting in between? You send request to your attacker impersonates you and sends the request to the legitimate PostgreSQL server. Then it gets the results back of your queries, and then it sends it back. You don't know. You can't really prevent this using default methods in SSL. So instead, what you do is, thank you. Instead, what you do is you use SSL mode verify CA or verify full. So just to give you a quick walkthrough of it, what happens is when a client sets up verify full as SSL mode and tries to connect with the database server, the server will send their certificate. Now, this certificate has something called chain of trust. What happens is your certificate is signed by someone, and then that certificate, and then it was signed by someone else. So there's this whole chain of trust that's present. The client is going to look at this chain of trust and figure out if the chain of trust is something it trusts. So if that chain of trust is something that the client trusts as well, it will allow a connection. That's what verify CA does. But then verify full adds an extra step. It will not just look at the chain of trust, it will also confirm from the certificate if the host present in that client, in that server certificate is the same as the host that it's trying to connect with. So this extra step is what adds an extra layer of security with, it adds an extra layer of security and prevents spoofing. So when you are setting up your database, I would recommend use verify full to set up SSL. Can you please can you please move to the next slide? Okay, thank you. But then there's a challenge. When you're using certificates in your database server, this can be an operational nightmare. The reason being, when you're setting up certificates, you don't just have to set up certificates, you also have to rotate them, you also have to revoke them. After a while, maybe that you have to set up a new instance, and in that new instance your server will be present. How do you go about the whole revocation list? So all of these steps are very challenging. So I thought of setting I thought of an architecture that I'm sharing here. Maybe this isn't perfect, but I'm learning, so I thought of sharing with you. So what happens is, you keep your certificates in a secret manager, and within and that secret manager is also responsible for handling the certificate rotation. So once a certificate has been rotated, there is this sidecar or an agent that's present in your PostgreSQL server. What's going to happen is, this is going to this agent or sidecar is going to keep checking secrets manager and check if there's any certificate rotation happening. If a certificate rotation has happened, it's going to fetch the new certificate. Then it's going to write this certificate in your file system. Once it has written that certificate in the file system, it's going to signal PostgreSQL to reload the server. On reloading the server, it's going to fetch the new certificate, and now your certificate has been rotated. If you want to add another layer, instead of using the file system, what you can do is you can use an ephemeral file system, something called temp file system, TMPFS. I think the directory for this is /dev/shm. I could be wrong here, so maybe you can verify this. But this is something you can do to make sure that when you're using your certificates, you rotate them efficiently. To the next slide, please. Thank you. The next step, Scram. Scram is considered a great form of authentication, especially when using passwords. Reason being, Scram does not send your password to the server. There is no password sharing happening, which makes it secure. And the way it works is, Scram is the client is going to do some kind of proof. It's going to create a proof and send it back to the server, and that server is also going to check if the proof that client has sent is actually valid. And then server is going to send its proof back as well that client can calculate on their own. So if the client and the server proof match, a connection will be established. Now I mentioned that this is going to prevent spoofing. The way Scram SHA works is, if you so there's this another mode of Scram SHA 256 called Scram SHA 256 Plus, which enables channel binding. Channel binding means when you're creating your proof using the password, you're not just going to use the password, you're also going to use a hash of the server certificate. So this adds another layer of security, and it prevents spoofing. However, this is not enough. The first line of defense is always going to be your SSL. So when you use SSL mode as verify full, it works. To the next slide, please. Now, preventing SQL injection. Pretty much everyone knows what SQL injection is. I'm not going to get too deep into it, but I'm simply going to talk about different solutions that people have. So when you're trying to prevent SQL injection, the first step is literally to use parameterized queries everywhere. But then you can add another line of defense, which is a WAF. especially in an enterprise setting. So in an enterprise setting, what's going to happen is your client will connect to your server. What you can do is you can terminate your SSL at the WAF or before the WAF, and this WAF will have access to the payload that was sent in the request. So this WAF is going to look at that payload. It has these rules that it can use to determine if there was any kind of, if the payload matches with any SQL injection payload. If it does, or if there's some form of similarity, WAF is going to prevent that request from reaching your database server. So it just stops that request right there before it reaches your database server, which is why it's a great form of preventing SQL injection attacks. And the next good part of including WAF is that you don't just limit limit yourself to SQL injection payloads. You can set up rate limiting. When you're using WAF, you will also be inspecting your traffic. So terminating SSL becomes incredibly important. But then the next part is not just using WAF. When you're in your client end, you also have to make sure that your application's database role, when you're using your connection pool, you set up different connection pools with different permissions. So what's going to happen is you have for a particular table, you only need access to read queries. If you only need access to read queries, why are you using a role that gives access to another table with write queries? So if you start setting up connection pool, or you set up a connection with a role that gives you access only to what you need, you can prevent the damage that SQL injections can cause, because now it can only send read queries. Okay, the next slide, please. I think I rushed into it. It was supposed to be 25 minutes, right? Yeah. Okay, so this is the last slide in my talk, but there are also some appendix slides that I can talk about if we have some time. So your security checklist is you enforce scram SHA. These are the items that you're going to do today. And then these are the items that you should think about setting up in the longer run. So today, start enforcing scram SHA 256 instead of just using MD5 or trust. Do not use trust. Pretty much everyone knows about it, but just saying. Then you start hardening your operating system level permissions. Even when you, as a DBA, don't just think about your database. Also think about what's happening beyond the database. So what's happening in your instance? What exactly is happening in the server? And also think about what's happening at the application level, because these are your clients, and when they send you a payload, you are going to execute it. So how do you go about preventing? Is you harden your operating system level permissions. You monitor correctly. You set up PG audit. PG audit is for the long-term plan. You enable SSL and use host SSL to prevent someone else from snooping. Once you start looking at verify CA, you also prevent spoofing attacks. So that works very well. And then when you're setting up password, instead of using alter user query, you use /password command of PSQL. In the longer run, configure all of your clients to use SSL mode verify full. I'm not saying this is something that you can do right away, because it takes a while to, the whole migration is going to take a while. But if you can configure all of your clients to use SSL mode as verify full, it will help you prevent these spoof attacks in the longer run. Then audit your DB roles, grant the permissions on objects instead of giving permission on the entire database. This helps you prevent the damage that a SQL injection attack can cause. Set up audit trail using PG audit. This is something that I put in because when I started looking at PG audit, I found that I haven't used it yet, just so you know. So what I noticed was that PG audit also allows you to mask the passwords when you're using any DDL. So in the longer run, PG audit is, and also PG audit is much better than using your database logs directly. So use PG audit. And then the last step is you partner with your devs to eliminate non-parameterized queries in your application. So that's it for the talk. I don't know how much time we have. Oh, we have 10 minutes? So great. I can talk about some other things as well. So the last time I was doing this rundown, it took me 26 minutes. That's why I was a bit worried. Yeah. So when I was talking about the certificates, I found something interesting. Especially when we are talking about certificate rotation, uh, there are people who still use certificate pinning in production environment. Now this is great. It has been working very well. However, it has been becoming obsolete. And it has been becoming obsolete because of three reasons. First, the certificate lifetimes are becoming shorter. Right now, most of the people recommend using certificates for expiring the certificates after 90 days. The next reason is that intermediate certificates are also rotating more frequently. The challenge with rotating intermediate certificates is that if you have SSL, if you have SSL pinning enabled, certificate pinning enabled in your client side, what's going to happen is your server has your intermediate certificate has been rotated, which means the chain of trust has changed. So when the client the certificate that has been pinned in the client side also needs to be changed. So now it's a two-step process. And then the next part is certificate transparency logs are now being used. So in case a certificate is changing, you'll know about it in the logs anyway. So instead of using certificate pinning, it's much better to rely on the standard SSL mode verify full instead of relying on certificate pinning. It also and as I mentioned earlier, it creates problems when you have to rotate certificate because now you have to rotate your certificate on your server side on your database server as well as change the certificate pinning on your client side. So it creates more problems than it solves. And I was reading this Cloudflare article, and they have also been saying that it's better not to use it anymore. So yeah, let me see replication security. So I did not have much to talk about replication security because I honestly don't understand it very well. But there were certain items that I thought would be useful for you. So when you're setting up your replication, it's much better to have a dedicated user with only replication privileges when you're setting up replication streaming replication. Reason being, if that user has access to do a lot more than just replication, if replication server gets compromised, okay, thank you. If that server gets compromised, attacker will try to do more things, and you don't want that to happen. So restrict privileges to a minimum. Use only replication privilege. Use a dedicated user instead of using your super user. Then enforce encrypted connections. Again, no matter what kind of server you have, if you're using distributed SQL, distributed setup for your database, or you're using or you're setting up replicas, all connections should have SSL enabled. That's a bare minimum that I'm suggesting you do. Now, when you're setting up replication, you know what server it is, you know its IP address. Why not just whitelist it in listen addresses? If you can restrict replication to happen only at a certain IP address, the perks are when if there's someone else who's trying to impersonate that replication server, they can't connect because the IP address is because you know the IP address. So this is so you can start restricting IP addresses for replication, and then the last step is using certificate authentication. These are your servers. You are the one who have created them. You can also sign them. So that way you can prevent that way you can prevent someone else from impersonating, because there's the entire chain of trust that I talked about earlier. There's another slide, but since we are out of time, I can open this for questions. Yeah. Yeah, please go ahead. So Scram Shah, yeah. Yes. So the question was, what's the difference between SHA and Scram Shah? So SHA is a form of hashing. Scram Shah is a form of authentication, which uses SHA 256. So the difference is where you have a password, SHA is basically a function that says, hey, I have the password, I'll give you some value, which is what you call a hash. But when you start thinking about Scram SHA is a form of authentication. It's a process. So if I go back earlier, I think it's here. Yeah. If you go back here, this is what Scram SHA process looks like. You set up a TELUS handshake, then the server says I'm require you need to send me some proof. So there's this step, there's this whole process when it says it sends a message, and then you have to send some things, and then you have to the client has to also send a proof that it calculates on its end, and then server calculates that proof on its end, and then it sends it back. So this is what Scram SHA looks like. This is not the same as SHA 256, which is just a hashing technique. Yeah, please go ahead. Yes, it uses SHA 256, but what goes on is there's some math behind it. It does some kind of calculations. Does it make sense? Great. Is there any other question? Sorry? So the question is using a private IP address good idea for replication? I would say yes, because these are your servers, and if you start routing those requests through the internet, or your replication instance is made public, I don't know how many of you remember, but there have been several situations where a database instance was left in public. And the challenge was people started experimenting, people started playing around with those instances, they started sending malicious queries. And because of this, DeepSeek had a big leak in their ClickHouse database. So same thing is going to happen with the replication instance as well. Potentially, I'm not saying it's always going to happen, but if someone figures out, they'll potentially try to send some kind of payloads and see if they can get more data out. So it's better to keep all of your servers internally. When I say internal, I mean in your internal network, instead of making them public. So yeah, I hope this answers your question. Great, thank you. Is there any other question? Okay, thank you.